Hey, everybody. Welcome to Unit 16, Episode 3. The laziness continues. I'm going with Middleton's notes again, so be it. All right, so last lesson was all about arithmetic sequences where you add a particular number called the common difference to get the next term. Today, we're learning about geometric sequences and series. And what does geometric mean? It means you're multiplying. And what are we doing here? Okay, we're multiplying by 3, are we not? We're multiplying by 3. 2 times 3 is 6, 6 times 3 is 18. You might say in the second one, you're dividing by 3. And you would not be incorrect, but that's not how we write it. We always write it as what you multiply by. So what's the same as multiplying by 3? I'm sorry, what's the same as dividing by 3? Multiplying by 1/3. So instead of using the letter D, like we did with arithmetic sequences called the common difference, we use the letter R to determine what you are multiplying by. So here R equals 3, and here R equals 1/3. R is the term you're always multiplying by, okay? And so you multiply by R to get from term to term. And to find R, here's the formula, which is, by the way, not called the common difference. It's called the common ratio. I don't know why she wrote ration. Common ratio, because here it is right there, common ratio. Okay, to find the common ratio, you could take any term, and instead of subtracting the term before it like you did with D, you take any term and divide the term before it. So R could be 6 divided by 2. R could be 30 divided by 90, not the other way around, not 90 divided by 30. 30, second term divided by the first, or third term divided by the second. Any term divided by the previous term. So example 1, is this a geometric sequence? Dun, dun, dun. Is it a geometric sequence? I wonder. Let's find out if this is a geometric sequence. The first thing I do is I figure out if R is consistent throughout the problem. So I could take the third term and divide it by the second term if I want to. Root 2 divided by 1 is root 2. So we get root 2 as an R value right here. But don't do just once, all right? Don't just calculate R one time. Calculate it at least 2 times. What if I did the third term divided by the second term? Well, that's what Mrs. Middleton did right here. 2 divided by root 2, then you rationalize and you end up with R equals root 2. So you got R equals root 2 twice. So the answer is yes. This is a geometric sequence, and R equals root 2. Example 2, find the 18th term of this formula. You can tell this is definitely not arithmetic. You're not adding the same thing each time. Just as a review, the nth term formula for arithmetic, it looked like this: a sub n equals a sub 1 plus d times n minus 1. Hopefully you recall that. That was 24 hours ago, 48 hours ago. So what does the nth term formula look like for geometric? It's a sub n again, the nth term equals the first term, but then instead of plus, it's times R, and then instead of times n minus 1, it's to the power of n minus 1. Think about that for just a second. When you multiply something 5 times, repeated multiplication can be found simply by raising to an exponent. So first thing Mrs. Middleton did was she took the second term divided by the first. 4 divided by 3, 4/3 is R. Then just plug and chug, man. To find the 18th term, you're going to take the first term, which is 3, parenthesis. I always put R in parentheses, times 4/3, and then raise it to 1 power less than the term you're looking for. So in this case, the 17th power. Now, Mrs. Middleton didn't calculate it. I want you to calculate it. Can I use my calculator, Mr. Cody? Absolutely, positively. Use your calculator. So just do 3, parenthesis, 4 divided by 3, close the parenthesis, to the 17th power. Type it the way you see it. 399.098. Now, in case you're unfamiliar with the little trick, if this happens to be a rational number, you could hit math, enter, enter, and it will write it as a fraction, which in this case, it must not be a rational number. This must be irrational and continuing along. But 399.098, here's my answer. I want you to calculate it. Use your calculators though. 399.098. There's my answer right there. Given a geometric sequence whose first term is 5 and whose fifth term is 81 over 125. Find the sequence. In other words, this is really what she means. Find the 3 geometric means between 5 and 185. Okay, so I know she did all this right here and showed all the work, but let me write this from scratch. So I have 5, and then I have dash, dash, dash. Those are the 3 means, and then 81 over 125. Okay, so basically I need to find the number to multiply by to find these 3 things. What is the number that you multiply by to get each of the terms? It's R. So when you find arithmetic means, you're looking for the letter D. When you are finding geometric means, you are looking for the letter R. And so I know Mrs. Middleton showed all her work right there, but let me show it once again. I'm going to write the geometric formula. A sub n equals A sub 1 times R raised to the n minus 1 power. So the A sub n is the last term. That's the 81 over 125. A sub 1 is the first term. That's the 5 times R. That's what you don't know. What is n once again? And I'm going to use a different color pen for this. N is all the terms, including the dashes and the numbers. So there's 1, 2, 3, 4, 5 total terms here. So I'm going to raise it to the 5 minus 1 power. That is how you find R. So from here, I'm going to use Mrs. Middleton's work. So 81 over 125 equals 5R to the 4th. Then she divided by 5, or she multiplied by 1/5 and 1/5. So here they cancel, and here you get 81 over 165. Then what did she do? All right, she took the square root of each. All right, and cut it down to be honest with you, you know what I would do from this point right here? I would just take the 4th root, the 4th root, and the 4th root. I think you all can do that. What number multiplied by itself 4 times gives you 81? 3. What number multiplied by itself 4 times gives you 625? 5. But look, this is hugely important right here. It's not just positive 3/5, it's plus or minus 3/5. Why? Think of when you are squaring something. What squared could give you 9? 3 times 3, but also -3 times -3. So what you need to do is you need to multiply by positive 3/5. Then you need to multiply by -3/5. And if you multiply by 3/5, you're going to get, and just 5 times 3/5 is 3. 3 times 3/5 is 9/5. 9/5 times 3/5 is 27 over 25. Okay. Then if you multiply by -3/5, and that's a negative right there, you'll get 5 times -3/5 is -3. -3 times -3/5 is positive 9/5. And positive 9/5 times -3/5 is -27 over 25. So if you wish, if I want to do it in another color altogether, orange, I could just write plus or minus 3, only positive 9/5, and then plus or minus 27 over 25. So this right here, if I box it, those are my 3 answers to that question right there. All right. You know, all of Mrs. Middleton's work aside, I hope that the explanation has helped things out right there. And there we go. There are my answers. Now, what if your exponent ends up not being an even power, like square root to the 4th? What if it was r cubed? All right. If r cubed equals something, will you get plus and minus as a value for r? Think about this. What if r, just for instance, hypothetical. What if r to, oh my gosh, I think I'm running out of space here. What if r to the 3rd power equals 8? Then when I take the cube root on both sides, r equals, does r equal plus or minus 2? No. The only number multiplied by itself 3 times, t equal 8, is positive 2. Case in point, when you're doing your homework, if you give r raised to an odd power, your answer is either only going to be positive or only going to be negative. So this is a hypothetical. Hypothetical. Okay, now what's the sum formula? There it is. First term, and I sometimes make it a point just to write a sub f, first term. Could be a sub 1, but in general, it's the first term. 1 minus r, which is the common ratio, raised to the n power, the term number, divided by 1 minus r. Find the sum of the first 5 terms of this geometric sequence. So 3, 6 fifths. Yeah, that's a 6/5. That's a divided by sign right there. It's not a comma. Okay, so first find r. Second term divided by first term. 6/5 divided by 3 reduces to 2/5. Okay, if you have questions on that, email me. So then I take the first term, 3, and then 1 minus r, which is 2/5, raised to the power of n, which is 5, divided by 1 minus 2/5. Now listen, you can do all this by hand if you want to, and Mrs. Middleton goes through in class how to do that by hand. I'll be honest with you, I will allow you to do this on your calculator. Okay, 2/5. In this particular case, 2/5 is 0.4, but suppose it's not. Suppose it's like 1/3. Don't round that to 0.33. Write it as 2/5. So just type it. 3, parenthesis, 1 minus 2 divided by 5 raised to the 5th power. Oops. Hold on, let's go back to the problem. And make sure your parentheses go in the right place. Yeah, it's 1 minus 2/5 and then to the 5th. So that parentheses shouldn't be there. Apologies. Let's go back and delete minus 2/5. I'll even put 2/5 in a parenthesis. 2 divided by 5, close the parenthesis to the 5th power, and then I can close that parenthesis again. And to be honest, I would hit enter right there. Because it's a fraction, I would do it in pieces. Don't round that off. I could just now do divided by, start a parenthesis, 1 minus 2 divided by 5. Your calculator does order of operations for you, but then close that parenthesis, 4.9488. Okay, so I did my numerator, I hit enter, I divided by my denominator, I made sure I included parentheses, 4.9488. And again, if I want to write that as a fraction, math, enter, enter. 3,093 divided by 625. If you knew that already, great. If you didn't know that, good on you. All right, so 4.9488. By the way, that's exactly what Mrs. Middleton got right there, 4.9488. If she wants it as an improper fraction, we could do that. If you want to write it as a decimal, you can. Just to make sure that, just to prove that that's exactly what we got, that's exactly what we got. How cool is that? Okay, so let's get down to the last 2 problems and we're done. Evaluate the sum as I goes from 1 to 12 of 4 times 0.3 to the I minus 1 power. How do you know whether a sum formula is arithmetic or geometric? Here's the answer. If there are no exponents, it's arithmetic. If you see an exponent and the exponent has a variable, it's geometric. If you see an exponent but it's numerical, it's actually neither. All right, so in order to be geometric, your variable has to be up in the exponent here. All right, so again, I know Mrs. Middleton wrote this sequence right here, but suppose you didn't know that. Okay, first and foremost, I've got good news for you. R is whatever the base is, whatever's being raised to the exponent, only the base, there's your R. So R is 0.3, and look, that's what Mrs. Middleton found anyway. All right, so then what other things do we need in order to find this sum? The sum formula found R, it found the first term, and the first term in this case is going to be a sub 1. How do I know it's a sub 1? Because that's the first number right there. Okay, and the first number is going to be 4. Why? Because if I plug in 1 right here, 1 minus 1 is 0. Anything to the 0 power is 1, and 4 times 1 is 1. Last but not least, I need to know n. N equals 12. So she plugged it all in. She did it 2 times, probably did it in 2 sets. Did the numerator hit enter? Did the denominator, and got 5.714. So the great news for this is that R is just the base. Evaluate the sum as k goes from 0 to 6 of 6 times negative 1/3 raised to the k power. Here's let's do it without even double checking. R equals, again, you're not going to know this. Who cares? Like, that's not even going to be there. R is negative 1/3. Not from looking at Mrs. Middleton's work, but from looking at the base right here. R is negative 1/3. Cool beans. The first term is going to be, in this case, a sub 0. Why? Because the bottom term is 0 there. And so that's going to be 6 times negative 1/3 to the 0 power. This all just becomes 1, and your first term is 6. Boom. There's a negative 1/3. Plug this all into your calculator. And like I said, you'll get 4.502 on your calculator, but if you hit math, enter, enter, you get 1094 over 243. All right. Oh, last but not least, for number 6 here. How did she know to raise it to the 7th power? Remember, to find n, this is the last thing I'm going to go over today. I could take top term minus bottom term, but then don't forget to add 1. Why are you adding 1? Because you're including the bottom number and the top number. Okay, count it on your fingers. 0, 1, 2, 3, 4, 5, 6. That's 7 total terms. All right, I hope you found this helpful. If you have questions, ask. Bye.